So we've gone over the fundamentals of how to speak computer, but we really haven't gone over the power that you have with Java. You see, code is meant to be read by people first and computers second, not the other way around. And what Java has as an object-oriented programming language is the ability to encapsulate ideas to help us know where to put code and what it does. So let's go over what that encapsulated thing really means as our first intro into object-oriented programming. Okay, so here I have a class, joke. And there's two things that have to go along with any type of object I'm going to create. There's state, and then there's behavior. We usually use variables to represent state, and then we use methods to represent behavior of things we want to do. So this idea of a joke has got to have a setup and a punchline. And you can see here that I definitely have a setup and a punchline string. Okay, well, that's fine, but they're not really set to anything. I'm going to need to actually create some behavior to actually store those setups and punchline pieces inside of this object, and then also get them out. So let's say I create a constructor for joke, and watch what I name this, because it's very important. I'm going to call it a joke setup, and then a joke punchline. This is a really important thing to remember, is that we don't know what's going to be passed in here. It could be a setup for one object, or it could be the setup for a second object, or even a third. So I could just say that joke setup is equal to a joke setup. Well, that's fine, but let me show you something a little bit more clear. What would happen if I were to name this just joke setup? If I now type joke setup, are we referring to the one that was just passed in, or are we referring to the one that we have with our particular instantiation? Well, the way that we can determine that is by using a keyword called this. This is going to refer to our particular object instantiation. Remember that this isn't an actual object yet. It's just a blueprint for making one. But when we're actually created and instantiated, we need a way to refer to ourselves. So by saying this joke setup equals joke setup, I can differentiate between the difference of the one that comes along for my particular object and the one that was just passed in. So let me go ahead and finish this up and say our joke punchline is equal to a joke punchline. Great. Now, if I were to go outside of our activity and actually create a new joke, let's say joke j is equal to new joke. And then I'm going to have to now put into my constructor the two setup and punchlines. So I wondered why the baseball was getting bigger as our joke setup. Then it hit me is the punchline. So I zoom out here. That particular j is going to be equal to a new instantiated object in memory, and that j is going to have its very particular setup and its very particular punchline set to those strings. So if I now do another joke, and let's say I learned sign language as my setup and my punchline, it's very handy. Now that particular object, another joke, it's going to have its own setup and its own punchline as a different state. So even though we're having just one particular reference of joke setup and joke punchline with the joke class, we actually have, in this case, 4 different strings. One that's the setup for j and the punchline for j, but we also have a setup and punchline for another joke. So the problem is that when we're outside of our object, it's really easy to refer to those particular variables. I mean, unless they're private. But we'll get to that in a little bit. Inside joke, you can't really say your particular instantiation. And that's where the this word allows us to refer to our particular instance. So being able to describe state and behavior inside of a class is what is going to allow you to write code that you can then reuse later in a very human-friendly, readable way about its purpose and use.